We're going to take a look at how to read and draw what are called bond line drawings. Within organic chemistry, we need to be able to recognize and read the structures that organic chemists use. So when we see a drawing of a molecule, we should be able to read all of the information that is given. We see three different types of molecules or structures in organic chemistry. We see the structural formula, which looks like the Lewis structure that we've seen before, where you see every atom and every bond. We also see the condensed structural formula. With the condensed structural formula, we see all of the CH groups condensed. So for example, here we see a CH3 and a CH3 bonded to the same carbon. So here we see CH3 bonded to a carbon. So they take all of the CH groups and they just condense them together to give us a much more shortened and easier to read version. And then the last type that we see is a bond line drawing. And a bond line drawing is actually very unique because it just shows the carbon skeleton. And so it's the quickest to draw and actually the easiest to read and best way to communicate. So we're going to take a look at how to read and draw these bond line drawings to make it easier for us as we look at organic chemistry. So bond line drawings, like I said, show the carbon skeleton with any functional groups that are attached. So at the top of page 2 of your notes, you see a list of functional groups, things like amines, which are NH2 groups, ethers, which have an oxygen in the middle. Maybe we see an alcohol that has an OH group. Those are functional groups. We see the functional groups, but we do not see carbons and hydrogens. These bond line drawings are drawn in a zigzag format. Each corner and end point represents a carbon atom. And so, for example, this molecule, every one of these points represents a carbon atom. So at the end, wherever two lines meet, there are carbon atoms. So this has 1, 2, 3, 4, 5, 6. Now, if you take a look at this, one line means it's a single bond. And so we have a carbon, single bond, carbon, single bond, carbon. If it's a double bond, we see two lines. So for example, this molecule in the bottom left, we have 1, 2, 3, 4, 5 carbons here. So we have carbon single bonded to a carbon, but then these two lines represent a double bond. So that means that this carbon is double bonded to this carbon. And then triple bonds are shown with 3 lines. So we see single bond here. We even have a single bond between this carbon and this carbon, but then there's a triple bond between this carbon and this carbon. So if we count the carbons, 1, 2, 3, 4, 5, 6. Now, when we look at double and triple bonds in bond line drawings, it's important to make sure that we draw a multiple bond in a straight line rather than a zigzag, especially triple bonds, because triple bonds are linear. So it might be kind of confusing at first to tell how many carbons there are, but just keep in mind that when we see a structure like this on the left, it's the same as what we see here in the middle. So carbon, 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 triple bond, carbon, carbon, carbon. Sometimes we see a gap on either side of the triple bond just to help us recognize that we have 1, 2, 3, 4, 5, 6. So this structure in the bottom left is the same as this structure on the bottom right. So comparing single bonds to triple bonds, here we have all single bonds. So notice how we have C's single bonded to all of the H's. So if we want to draw this structural formula in a bond line structure, we take 1, 2, 3, 4 carbons and we put it in a zigzag pattern. 1, 2, 3, 4. We do not show any carbons or hydrogens that are attached to carbons. But then if we take a look at this bottom structure, so we have carbon single bonded to carbon, triple bonded to another carbon, and single bonded to another carbon. Notice how it's actually drawn in a straight line, because you do not want to put a triple bond in a zigzag pattern because triple bonds are linear. So we're going to take a look at some examples. We want to count the carbon atoms. So before we learn to actually draw them, we need to be able to recognize how many carbons there are. So we're going to count the number of carbon atoms on each of the following, and we want to label them. So remember that corners and endpoints represent carbon atoms. If we take a look at example 1 here, notice there's an oxygen. So we actually show any atom that is not carbon or hydrogen. And we'll talk more about the hydrogens. Those are unique. We'll talk more about that in a second. But here we see an oxygen. So obviously that's not a carbon. So that means we have carbons at each of these endpoints of this first hexagon. So when we take a look at this first hexagon, we have carbon, carbon, carbon. All right, so we have 6 carbons here. Notice the 2 lines on some of them represents double bonds. So here we have a single bond, here we have a double bond. So we have 6 carbons on this ring, but then that's attached to this carbon in the middle. So this carbon is single bonded to this one and single bonded to this one and double bonded to an oxygen. And then we count the carbons on the other. 1, 2, 3, 4, 5, 6. So if we add all of these together, example 1 has 13 carbon atoms. 13 carbon atoms. Example 2, we take a look at this. So again, every end point and corner represents a carbon atom. Here again, we have a double bond to an oxygen. So this is an oxygen, not a carbon. So we have 1, 2, 3, 4, 5, 6. So we take a look, we circle each of these, 1, 2, 3, 4, 5 in this long chain, and then 6 is here. So example 2 has 6 carbons. So see if you can work through examples 3, 4, and 5. So pause the video and see if you can work through these 3 examples and then hit play and check your answers. So we take a look at example 3. So here we have a pentagon and we have a double bond off of it. So we have 1, 2, 3, 4, 5 carbon atoms in the ring. And then we're also going to have a carbon atom on the other side of this double bond. So we have 1, 2, 3, 4, 5, 6 carbon atoms in example 3. We take a look at example 4. Notice we have 2 oxygen atoms as part of this structure. Well, oxygen isn't carbon. So we have 1, 2, 3, 4. So example 4 has 4 carbon atoms. Now example 5, notice all of the oxygens that we have here. Every other endpoint and corner will represent a carbon atom. So 1, 2, 3, 4, right? This represents a double bond. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We count 10 carbon atoms here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Every corner, every endpoint is a carbon atom. So now we're going to look at counting hydrogens. So counting hydrogens is a little bit different than carbon. Most hydrogen atoms are not shown. So we would call these implicit hydrogens, meaning that we don't see them, but they're there. And so it allows us to quickly make a bond line drawing. But hydrogen connected to any other atom, NOS, must be drawn in the bond line drawing. The only ones we do not draw are the ones that are attached to carbons. And so if you take a look at this, notice how the only hydrogens that we see in these top 3 are the ones that are attached to a more electronegative atom, NO and S. Otherwise, notice all of these carbons do have hydrogens attached to them, we just don't see them. So notice in this structure at the bottom, again, all of these carbons do have hydrogens attached to them, but we do not draw them if they're attached to a carbon. So the rule for counting carbons and hydrogens, here's the rule. And so the rule for counting how many hydrogen atoms are connected to each carbon atom. Carbon atoms have a total of 4 bonds. Carbon can have 4 orbitals, so carbon atoms will have a total of 4 bonds. If we take a look at this example, exercise 12, the following molecule has 9 carbon atoms. So double check and see, can you count where the 9 carbon atoms are? Well, every carbon if it does not have 4 bonds already, every carbon will be attached to hydrogens to make up for the 4 bonds. So if we take a look at the initial structure, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we take a look at each one of these carbons. This first carbon, so this one right here, only has one other bond. It has a single bond attached to it, which means it's going to have 3 hydrogens. So at the end, this will be C bonded to 3 hydrogens. This second carbon has a single bond on one side and a double bond on the other, so that one already has 3 bonds. That means it's only going to have 1 hydrogen. Now take a look at this one in the middle here. So this one in the middle here has a single bond on one side, a single bond on the other side, and a double bond to oxygen. It already has 4 bonds, so it's actually not going to have any hydrogens attached to it. So notice how some of these, this carbon here, for example, has a single bond on one side, a triple bond on the other. It already has 4 bonds. So take a look at this example and this answer and make sure you understand why each carbon has the number of hydrogens that it does. So looking at these examples, it says put in the implied hydrogens to the following structures. So when we want to look at these implied hydrogens, remember first we want to identify where the carbons are. So we have 1, 2, 3, 4, 5 carbons here. Each carbon needs to have 4 bonds. So every carbon should have 4 bonds, whether it's to another carbon or to a hydrogen. So this carbon right now has 1, 2 single bonds, which means I'll see a hydrogen and a hydrogen. This carbon has 1, 2 single bonds, but it needs 4, so it's going to have 2 hydrogens attached to it. All of these, every single one of these carbons have 2 single bonds to other carbons, meaning that each one of them are going to have 2 hydrogens attached. Take a look at this one. 1, 2, 3, 4, 5. There's 6 carbons in this. Just like this cyclopentane molecule, here every carbon has 1, 2 single bonds, so it's going to have 2 hydrogens attached to it. So every single one of these will have 2 hydrogens attached. So this is getting us between the bond line drawing and the structural formula. Now looking at this, here's 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. This carbon on the end only has a single bond to another carbon, meaning that this is going to have 1, 2, 3 hydrogens attached to it. This carbon in the middle, 1, 2, 3 single bonds, so this will have 1 hydrogen attached. Each of these carbons on the end have 3 hydrogens attached because they only have 1 single bond. This one has 3 hydrogens attached. This one on the end, 3 hydrogens attached. So looking at this carbon in the middle, 1, 2, 3 single bonds, so it needs another hydrogen to make it have 4 bonds. This carbon in the middle, 1, 2, 3 single bonds, it's going to have 1 hydrogen attached. And then this carbon, 1, 2 single bonds to other carbons. So if it needs 4 bonds, it needs 2 hydrogens attached. So notice how if you want to show all of the carbons and hydrogens, it can start to look really messy. That's why we use these bond line drawings, but it's important that you can tell how many hydrogens there are. So we've looked at reading bond line drawings. Now we're going to look at how to actually draw them. So we're going to take the following molecules for example. We see these structural formulas. They look like Lewis structures that we've drawn. To put them into bond line drawings, we just focus on the carbon skeleton. And then we draw any atoms other than C and H. Now remember, any hydrogens that are attached to anything other than carbon should be added to the bond line drawing. So notice here we have 1, 2, 3, 4, 5, 6 carbons in the skeleton. So I would start by drawing 1, 2, 3, 4, 5, 6. And then off of one of the carbons, we have an O single bonded with an H attached. So here we have an O single bonded with an H attached. Now, if you drew it down here, that's fine, right? If you drew the oxygen, the OH group down at the bottom, that's okay, because I could just rotate this molecule and get the same thing. Notice this next one. We have 1, 2, 3, 4, 5, 6 atoms in this ring, but one of them is an oxygen. So 1, 2, 3, 4, there's my 5 carbons with the oxygen. So I start by drawing this ring structure, and then I notice I have 2 CH3 groups off of this carbon. Single bond to a C, single bond to a C. The only time we show the H's is if it's attached to something other than carbon. So tips to follow for drawing these structures. So remember that carbon atoms in a straight chain need to be drawn in a zigzag format unless it's a triple bond. And so here we see 1, 2, 3, 4 carbons. It's going to be drawn like this, 1, 2, 3, 4 carbons, but it's in a zigzag format. If you're drawing double bonds, draw the double bond as far away from the other bonds as possible. So notice here we have 1, 2, 3 carbons, but we have this double bond to an oxygen. We want to draw it like the structure on the left because the double bond is as far away from the other 2 bonds as possible. So that's much better than this one that's on the right. Notice this says this is a bad drawing because all of the bonds are really close together. When you're drawing a zigzag format, it doesn't matter which direction you start drawing. I typically start at the bottom and draw up, but you could start at the top and draw down. But notice each one of these has 1, 2, 3, 4, 5 carbons in the long chain, and then 1 carbon single bonded to the middle. All of these show the same thing. So some mistakes to avoid. Never draw a carbon atom with more than 4 bonds. Always double check and make sure that your carbon atom only has 4 bonds because it only has 4 orbitals. So that means that you could have a carbon all single bonded to hydrogens, you could have a carbon with a triple bond and a single bond, but either way it needs 4 bonds. When drawing a molecule, you either need to show all of the H's with all of the C's, or use a bond line drawing where C's and H's are not shown. You cannot show something like this, right? You cannot draw the C's without the H's. So if you want to show all of the C's, then you have to show all of the H's attached as well. So if you leave out the C's, you would use a bond line drawing like this. That's going to be preferable. It's going to be faster. It's going to look a lot neater than this one on the right. This one on the right is correct as well. You have to put all of the H's in if you want to actually show all of the C's. But this bond line drawing is easier and it's quicker. And then when drawing each carbon atom in a zigzag, draw all of the bonds as far apart as possible. Just like we talked about with the double bond, you want to even do it with single bonds. So having it drawn like this with the single bonds both pointing down is actually better than one of them pointing up and one of them pointing down, because in this right side of the molecule, you actually have these 3 bonds that are closer to each other than if you tried to separate them as much as possible. And that'll get better as you practice drawing. So now some of these problems, you have to actually draw a bond line drawing. Here's what I would recommend as you're drawing these. Find how many carbons you have in a chain. So here I have 1, 2, 3 carbons. That's my longest chain. So I would start by drawing 1, 2, 3 carbons in a zigzag pattern. 1, 2, 3. Then I see off the middle carbon I have 1, 2 single bonds. So I know this looks a little weird, but this is actually how I would draw it. 1, 2, 3 carbons, and the carbon in the middle has a single bond to a C, a single bond to a C. Look like this. I want you to see if you can work through the other 3 problems. So you have 22, 23, and 24. I'll give you a hint with 22. Again, start with this long chain. You have 1, 2, 3, 4, 5, 6 carbons in a long chain. So start by drawing 1, 2, 3, 4, 5, 6 carbons in the long chain, and then add your double bond to an O and add this CH3 group. So see if you can work through these problems, and then we'll go over any questions in class.